Hello again. Now we look at log laws. So logs and indices are exactly the same thing looked at in different ways. So if I have, for example, here x equals b to the a, where b is the base and a is what we used to call the index over here for indices. If I take a look at this way, I say the log of x to the base b is equal to a. So this is a log in this case as viewed in this way. In other words, I'm looking at, when I look at the log of x to the base b, log of x to the base b, I require the number I will raise b to get x. So if I raise b to the power a, I get x. That means the log of x to the base b is equal to a. And this is the interplay between logs and indices is very important because a lot of problems to solve are looking at going from one to the other. So essentially, this is what this means. Log of x to the base b is equal to a if and only if x is equal to b to the a. Simple ones. Well, since 2 cubed is equal to 8, that means log of 8 to the base 2 is equal to 3. 100 is 10 squared, so log of 100 to the base 10 is equal to 2. 27 is 3 cubed, so log of 27 to the base 3 is equal to 3. And here, well, I know that 16 is equal to 2 to the 4. So the log of 16 to the base 2 is equal to 4. Likewise here, I've got the repetition here, log of 16 to the base 2. Can I change that to log to the base 4 in that case? So now 16 is equal to 4 squared. So that means log of 16 to the base 4 is equal to 2. 81 is 9 squared. So log of 81 to the base 9 is equal to 2. And 32, tricky, is actually 2 to the 5. Which 2 is the square root of 4 to the 5. So that becomes 4 to the 5 on 2. So 32 is 4 to the 5 on 2. So the log of 32 to the base 4 is 5 on 2. So here I require to express 32 in terms of 4 first before I can write the thing as a log. That's how all those work. Log laws are similar to indices laws. The first is if I've got a log of x times y, that should be lowercase y, looks like it hasn't changed, log x times y, that's the same as log of x plus log of y. Log of x to the power r is r times log of x. Log of x over y becomes log of x minus log of y. Log of b to the b is equal to 1. And log of 1 to the b is 0. So for these you'll find proofs at the end of the slides and you can have a look at them yourself. So let's see how these work. It says convert the following exponential equations into logarithmic form. So the first one here essentially means that if I take log of 81 to the base 3, I get 4. The next one means if I take log of 128 to the base 2, I get 7. Next one means, this is the double arrow means if and only if, means I can go forward and I can go backwards. If I take log of 100 to the base 10, I get 2. And that means if I take log 16 to the base 8, I get 4/3. You can try the last one. If I take 8 to the 4/3, you should get 16. So the way it works is 8 to the 4/3. That's 2 cubed to the 4/3. That becomes 2 to the 4. And that is equal to 16. 625 is 625 square root of. All that means is 625 to the half. So that means log of 25 to the base 625 is equal to a half. 7 is equal to 2 to the x. That means log of 7 to the base 2 equals x. 7 is equal to a squared, means log of 7 to the base a equals 2. 2. So this is just the interplay between logs and indices. Move on a little bit. Convert the following logarithmic equations into exponential form. So that essentially means that if I take a look at 81, that should be equal to 3 to the 4th. That means that 125 should be equal to 5 cubed. 125 should be equal to 5 cubed. That means that 64 should be equal to 4 cubed. That means that x should be equal to 7 cubed. That means that x, oops, 8, sorry, going too fast. That means 8 should be equal to 4 to the x, and that means that 12 should be equal to b cubed. Use log laws to simplify these. So here we need to use log laws. However, log of 8 and log of 3, as long as the base is the same, that means that's the same as log to the base 2 of 8 times 3. I mean, it's the same as log of 24 to the base 2. Subtracting means I divide the numbers, so log of 7 minus log of 21 is the same as log to the base 3 of 7 on 21. And that's log to the base 3 of 1/3. And that's log to the base 3 of 3 to the minus 1. And that becomes -1 times log of 3 to the base 3. And log of 3 to the base 3 is 1. So this works out to be -1. This here is tricky. I've got different bases here, 16 and 8, so I must write both of them in terms of the same base. You can choose either 16 or you can choose 8. Either way you can simplify this. What I'll do is I'll reduce this to the base 16. So 64 is 4 cubed. So that is the square root of 16 cubed. So that's 16, the square root is a power of a half to the 3 halves. So that means log 64 to the base 16 is equal to 3 halves. So that's the first part. That's 3 halves. And of course, log of 64 to the base 8. That's just 8 is 64. 64 is 8 squared. That's 2. So this works out to be 2 and 1.5, 3.5, 7 and 2. Takes away working out here. The second part is easy. Log of 64 is simply 8 squared. Log of 64 to the base 8 is 2. But this part here, you need to write that down in terms of something common. So 64 is 4 cubed, and this root 16 cubed. So that means it's 16 to the 3 halves because the square root is a power of half. That means the log of 64 to the base 16 is 3 halves. Look at this one. Similarly, And I dare say this shouldn't be a 1 here, but it should be a 16 again. Typo there, I'll fix that. 64. Well, that's easy because this is log of 4 cubed to the 4, and this is log 16, and 64 we know is 4 cubed again, but 4 cubed this part here works out alright because I've got log of 4 cubed to the base 4 becomes 3 log of 4 to the base 4, which is 1. And this part here, I'll write therefore is 16 to the half. This is 16 to the 3 halves again, as we had before. And so this here simply is 3, and this is 3 on 2 log 16 to the base 16, that's also 1. This is 3 plus 3 on 2. Which is going to be 3, 4.5, 9 over 2. Sorry, 9 over 2, excuse me. So some of these things require just a bit more working out, but most of it is just playing with powers. So look at those yourself and make sure you understand them. Some more quick ones. I've got log of 2 to the base b is equal to x, and log of 3 to the base b is y. I want to express these in terms of x and y, so all I'm using here are log laws. So log of 12 here, log of 12 is log of 4 times 3, and I split that into log of 4 is 2 squared plus log of 3 to the base b, and 2 squared becomes 2 log of b, log of 2 to the base b, plus log of 3 to the base b, and that is 2 log of b, log of 2 to the base b is x, and this is y, so I get 2x plus y over here. Log of 18, so 18 is 9 times 2, which is 3 squared times 2, so this becomes 3 times log 3 to the base b plus log 2 to the base b, so this is 3 times y plus x. 4.5 looks a bit tricky. But we can figure it out. Let's have a look first at the last one, 1/6, which is much easier. So 1/6 here is the same as log to the base b of 6 to the minus 1. That's log to the base b of 2 times 3 to the minus 1. So that's essentially going to be minus log 2 to the base b, and then minus log 3 to the base b, that's minus x minus y. What about 45? Well, 45 I can write as 4.5. So 4.5 I can write in terms of is 9 over 2. So that's going to be log to the base b of 9 minus log to the base b of 2. And so log to the base b of 9 is 3 squared. This is just x, and this becomes 2 y minus x. So just a little tricky here. Be careful. You must express the numbers in terms of 2 and 3. That's all we have. So you can see 4.5 is 9 over 2, and it works from there. Likewise for the other ones. Let's have a quick look at these ones. It's to the base 10. Be careful. So log 60 is log to the base 10 of 6 times 10, and so that becomes log of 6 to the base 10 plus log of 10 to the base 10, and 6 is 2 times 3, so this is log of 2 to the base 10 plus log of 3 to the base 10, and of course log of 10 to the base 10 is 1. There's my x, there's my y, and there's a plus 1. B, log of 5 to the base 10. Well, that is the same as log to the base 10 of 10 over 2. So that's log of 10 to the base 2 minus log of 2. So let me log 10, base 10 here, sorry. This is log of 10 to the base 10 minus log of 2 to the base 10, and that's a 1, and that's my x. Similarly, 15, I can think of in various ways, but the simplest is to think of this simply as log to the base 10 of 30 on 2. So that becomes log of 30, which is 3 times 10, minus log of 2 all to the base 10, and so log of 3 to the base 10 plus log of 10 to the base 10, and minus log of 2 to the base 10. So the log of 3 to the base 10 is y, log of 2 to the base 10 is minus x, and the log of 10 to the base 10 is 1. The next part is looking at exponential and logarithmic equations, and we'll see that in the next lecture. Thank you. Bye-bye.